Yes.
All right, great. Okay, so we're talking about here. All right. Okay, can you see me writing?
Yes.
Okay, that's great. All right. Well, Nolly, tell me what you know about the waves, or what according to you is the waves.
There are many different kinds of waves, such as X-ray waves, UV radiation waves,
Mm-hmm.
uh, and gamma ray waves. And waves can come in high amplitudes and amplitudes and have different wavelengths.
Okay, so you're talking about, so your answer consisted of some parts of electromagnetic spectrum as well as some properties of the waves. Okay, so when I'm asking about the wave, so it is just like what exactly it is. So wave is basically, what is the structure of the wave before I tell you the definition? So I would like to know what is the structure of the wave. How does it look like?
It it looks it looks like a wave would, and it has a crest, a trough,
Uh-huh.
amplitude, frequency.
Wavelength, correct?
Yes.
Okay, so um, I'll give you an example over here. So just imagine this is a pond. Okay, this is the simplest of the example and the very easy example to understand. And say you have a rock in your hand. All right, so this is a small piece of rock that you have in your hand, and this is a pond. And in the pond, the water is kind of very still. Okay, there's no movement of water, absolutely. So what you do is you take a small piece of rock and you throw it into the water. So what happens?
The ripples
There
form.
are ripples. Okay, so how do we normally draw a ripple? We draw a ripple in this manner, correct? This is how we draw a ripple,
Yes.
right? Yes. So what exactly is taking place, or how is this ripples formed? So we will just see that, but then in this still water, you threw a stone, you threw a rock into it, you disturbed the stillness of the water, correct?
Yes.
Yeah, so that is basically caused something called as waves. So basically, if you have to define a wave, so what do we define that as? It is a disturbance that is caused in a medium. Are you understanding? It is a disturbance that is
Cause.
caused in a, yes, it's a disturbance. Just right here. That's a disturbance that is caused in a medium. So it's not necessary that it has to be a medium. Waves can even travel through a no medium condition also, absolute vacuum. You know it, right? Correct?
In
Do you know a wave can travel? Okay, I'll just tell you. I'll come to that. So is this clear? Like what is waves? Wave is basically a disturbance that is caused in a medium. All right. Now, why there is a disturbance, or why is this ripple kind of a structure formed in a wave? So let us see that. So just imagine, I'm coming back to my example here, the pond example. So here you have, just imagine this pond is made up of like n number of molecules. So what are molecules? Okay. So what happens is, so when you're throwing a pond, I mean, sorry, when you're throwing a rock into it, so when the rock was on the ground, it had potential energy. Okay, I'm just putting into a little of energy, going into a little depth. Okay, so when the rock is on the floor, it has potential energy. Do you agree to it?
yes.
Yes. Okay. So when you're picking it up, okay, and when the rock is basically into motion, okay, so it's coming down, or coming and hitting inside the pond. So the potential energy is basically getting converted to the kinetic energy. Okay. So what happens is, it is energy. Energy means what? What is energy? What is energy?
Energy is the movement and frequency of matter.
Movement and frequency of matter. In mechanics, how would you define energy? Like something that allows us to do work. Correct, no?
Yes.
Energy is something that allows us to do work, not only us, different objects. So now just imagine now this energy, the kinetic energy or simply the energy is passed on to the first molecule where the rock is hitting the water. So let us consider that as the first molecule. So what happens? The first molecule, it receives the energy and it gets excited. All right. So I'll just draw over here. You'll understand how a wave is normally formed. Okay. So this is the first molecule that is represented in over here. So what happens is this molecule gets the energy, it starts exciting. It is excited and it starts vibrating. Okay. Is this clear till this much?
Yes.
Yeah. All right. So what happens now? This is like, in an excited mode, it's vibrating. So what does it do is like it also passes on some energy to the neighboring molecule. So what happens? The vibration of the first molecule reduces and the second molecule's vibration increases. Okay. And then the process basically goes on. So when you are just transferring the molecule, transferring the energy from one molecule to the other molecule, the preceding, the one molecule which was like before, okay, that molecule's energy goes down. And yes, there's a wave kind of a structure that is being formed. See this, if I'm just joining, so does it look like a wave? We have one crest here. Correct, no? We have one crest here. And definitely it just goes on, continuing. So I don't have to basically draw it. Is this clear?
Yes.
Okay. And one important thing in this, it's a question to you, okay? So in this, there are two things. One is the, okay, the energy is carried, okay? Okay, tell me one thing. Energy or particle, among them the energy and the particle, which one is transported? There is transferring of energy that is taking place. The energy is transferred from first molecule and it reaches slowly to the next neighboring molecules. Correct, no?
Yes.
Yes. All right. So is